So hey everybody, thanks for coming. My name is Jamie, and for the next 30 minutes, I'm going to attempt to convince you that if you know Heroku, you can use Kubernetes. And I know that's a lot like saying, if you can dodge a wrench, you can dodge a ball. And while I'm not going to throw any wrenches at people, unless you ask me nicely and provide the wrench, because I didn't bring any with me, hopefully I can convince you that this is not too clickbaity of a title. So, Kubernetes. You can abbreviate Kubernetes with K8S. It's a numeronym, starts with a K, ends in an S, and then there are 8 letters in between. You may have encountered this sort of naming convention with words like internationalization, abbreviated as I18N, or accessibility, abbreviated as A11Y. It's kind of funny because it actually points out the fact that internationalization is a 20-letter word. So, what is Kubernetes? Now, you may have heard it referred to as a container orchestrator or potentially a container scheduler, which sounds a lot like how functional programmers describe monads, right? A monad is a monoid in the category of endofunctors. Well, that doesn't tell me anything. It's not wrong to call Kubernetes a container orchestrator or container scheduler, but it also doesn't really explain a whole lot. You can tell it's not a good explanation because how often people say things like, okay, well, what's that, after hearing the explanation. So we need a better definition. And so the purpose of explaining something is to help people learn, right? If your explanations aren't doing that, then when you're using fancy words, you're not teaching. So let's drop the fancy words and try and meet people where they are. Kubernetes is a platform for running containers. Orchestration and scheduling are definitely part of that, but that's the how rather than the what. Now, you may have heard of Docker containers in the past. Docker introduced a lot of people to the idea of packaging up your application and all its related resources into what we call a container. And a container is basically a tarball or a zip file containing anywhere from a single binary all the way up to a complete Linux operating system, minus the kernel. If you're curious about how they work, Liz Rice has a great talk about them from Container Camp 2016, where she live codes a primitive container in less than 100 lines of Go code. And so the summary for what containers are, is for the most part, it doesn't matter what particular Linux distro is running on the host or what packages it does or does not have installed. Your container has all the binaries and supporting files and whatnot so that it can run completely isolated from that host operating system, or effectively isolated from that host operating system. And so while containers are fundamental to these sorts of architectures, these scalable architectures, packaging a container is only part of the solution. We still need to be able to run them. And an application is only useful when it's running. And so that's what Kubernetes is doing. It's taking that container and actually running it. And how it does it is pretty interesting and surprisingly similar to how Heroku runs your dynos. In fact, if Heroku didn't exist today, Kubernetes might be something that you use to build it. Now, if you're familiar with Heroku, you likely already understand several concepts in Kubernetes, despite dramatically different vocabulary between them. For example, on Heroku, the unit of running software is called a dyno. In Kubernetes, that same concept is called a pod. There are some slight differences between them, especially in more complex Kubernetes architectures with things like sidecar containers. The main difference you'll see, though, is that while Heroku automatically provides the computing resources along with the dyno, right, you get the CPU and the RAM along with it, Kubernetes requires that you set up a pool of nodes beforehand to assign your pods to. And this is what the scheduling part of the container scheduling that I mentioned earlier. Scheduling is what Kubernetes calls assignment of pods to nodes. Nodes are just the basic server type that your cloud provider uses. And most cloud providers will automatically put those servers inside of your cluster. And so going back to this, the dyno on Heroku is roughly the same as the pod in Kubernetes. On Heroku, you set up multiple entry points to your application using lines in a proc file. For example, you might have proc file entries for your web server and your background job runner. Kubernetes calls these deployments. Now, Kubernetes doesn't put deployments underneath anything else the way that Heroku puts your proc file entries underneath your application. It's just an entry point into your application. So your web server and your background job runner would be two completely separate but nearly identical deployments within Kubernetes, differing only in the commands that you run. When you run git push Heroku, Heroku runs what's called a build pack, which installs your gems, compiles your JavaScript and CSS assets for production, and does any other preparation needed to just be able to take that slug and send it up and deploy it into production. The equivalent for containers is a Docker file. If you're building your containers with something that's not Docker, it might be called a container file instead. But regardless of which file name you're using or which implementation you're using it for effectively the same purpose. And so after Heroku runs your build pack, it takes all of those files and everything as a result of executing that script and puts them into a deployable artifact called a slug. And every time you restart your dynos or scale them out or anything like that, those dynos are running a copy of that slug. With Kubernetes, your Docker file results in a container image. Similar to the Heroku slug, every time you restart your pods or scale them out, it runs a copy of this container image, pulls a fresh copy, and then executes it. Deploying to Heroku with git push builds your slug, replaces your dynos with the new ones, and replaces your dynos with the new ones running the new slug. This is directly analogous to building a container, pushing it to a container repository, and then patching the necessary deployments with the new container image tag from that repository. Scaling up your dynos on Heroku can be done with the Heroku scale command through the Heroku CLI, or through the UI by dragging the dyno slider. With Kubernetes, you can scale the number of pods with the command kubectl scale deployment. So people pronounce that kube control. I pronounce it kubectl because it's adorable. But they're effectively the same operation, right? Heroku scale and kubectl scale deployment, same operation. When you need to restart your dynos for any reason, you run the Heroku restart command. Kubernetes makes the name here a bit longer. Kubectl rollout, restart, deployment, right? But it's the same idea. The main difference here is that Kubernetes does not restart everything all at once the way that Heroku does, at least not by default. What it will do is instead spin up a few new ones, a few new pods, wait for them to actually start running, and potentially pass any readiness checks that you've defined, such as handling requests successfully. And then it'll start terminating the old ones. And it'll do this in batches instead of all at once. So by default, I believe it's 25% at a time. So it'll do this 4 times. And this is highly customizable. You can spin up one at a time, right? Roll over one pod at a time. And one killer feature of Heroku is the add-on ecosystem. You can provision anything from databases to video encoding inside your application with just a few clicks. The Kubernetes ecosystem has a couple of different analogs to this, which one is called Helm charts, which installs things into your server as if it was like a package manager. Another is a pattern called operators, and where you define custom resources and run one or more pods inside your cluster that use the Kubernetes API to respond to changes in those resources. Now, Kubernetes uses the operator pattern internally a lot. So, like anytime you are scaling your deployments, you are actually there's an operator checking those numbers and verifying against the number of pods, the number of running pods. And if it's not correct, it will add or delete more as needed. Also, these Helm charts and operators are not necessarily mutually exclusive. You can actually use Helm charts to install operators into your cluster. But this is not, you can't just drop one for the other. They're not identical, right? There are trade-offs between using one or the other. Some of these trade-offs are about what you have to do. Heroku and platforms like it optimize for getting your code from development into production with minimal boilerplate. And so in that regard, Heroku's going to win that way more than, far and above Kubernetes. On these platforms, you don't have to write your Docker file or a build pack. They're already provided, right? You just go into the UI or the CLI and say, create this app, and then git push. If you're deploying an application that already has containers built, though, there isn't much difference in deploying on Heroku versus Kubernetes. And also, this is also similarly true if you're running CI. Once you have CI set up, your interface to deploying is still the same. You're git pushing to GitHub or GitLab or wherever you have your code hosted. And then your CI is taking care of all the details of deploying. Database upgrades. Sometimes this can be a pain on some of these platforms. And if you're using something like AWS RDS or any of the other managed platforms on other managed databases on other platforms, you might have a bit easier of a time than doing the same thing on Heroku. Another trade-off is about what another set of trade-offs is about what you can do. One of them is, for example, how much can you dig in? When so much of the operations side is abstracted for you, they may ultimately also be encapsulated from you, which potentially gives you little to no visibility into what's going on. If you've used Heroku, you may be familiar with trying desperately to figure out why something isn't working and just start restarting dynos and moving things around. Whereas a platform like Kubernetes can actually show you what's going on. But again, that extra visibility may be a bit overwhelming, and that's what's also one of the strengths of platforms like Heroku and similar ones. I already said that. Another is, what does it take to close off services to the public internet? I don't know if Heroku gives you that option. I'm seeing people shaking their heads. Apparently not. So basically, when you're running something on Heroku, you may not be able to cordon it off from the public internet and just have it available to internal services that you're running. And another is price. This is a trade-off in either direction, depending on how far you want to take it. I'm not going to get too far into that. That's dangerous. But speaking of dangerous, we're now going to do a live demo. We're going to deploy a Rails app to Kubernetes from my iPad. So we're going to get weird, right? So I've already got my Kubernetes cluster spun up on DigitalOcean just because it's easy. It's already running. The thing that we're going to do is we have some preliminary things that we have to set up inside of our cluster. For example, we're doing ingress, which is going to be able to route requests into our cluster from outside of it. So anything from the public internet, so that anybody can use it. This is not necessary, but I'm just installing it as a flex. Cert Manager, this is going to let us automatically provision TLS certs. This thing that I wrote myself, which means it may or may not work, so let's cross our fingers. And then some things that are specific to DigitalOcean load balancers, for example, validating TLS certs. We have to add a couple of annotations, and then we are going to run this, install this, define this cluster issuer. Almost nothing in here is specific to the cluster that I've just provisioned. None of it is specific to the Rails app that I'm going to install. Right. This is all. Most of this is relatively generic. Thank you. And on top of that, actually, let's go ahead and start that running, because this is going to take some time. We're going to run our provision script. And so this is installing all those different things into our cluster. And then what we're going to do here, so it pauses here to let the load balancer spin itself up. So we've got our, this is our cert manager, Nginx ingress, the Rails app controller, metric server. These are all the things that were in there, and then a whole bunch of stuff that's just necessary for Kubernetes to run, and it runs it inside of your cluster. And so we're waiting on this load balancer here to receive an IP address, and when that happens, we'll see this pending will turn into an actual IP address. And so while we do that, we can go back over here. I'm just going to come back. So this is what this is going to do is I got to fill some time here while that spins up. So we're running this. We're setting some annotations on our load balancer. Annotations are just like a little extra information, some basic key value stuff. Basically saying that our host name is just a novelty domain that I have spun up for myself, and we're giving it a name so that it'll be easier for us to see it when we wire up our DNS to it. That's the only other bit of configuration that we need to do, and this is the reason we need the IP address, or one of the reasons we need the IP address. Nothing yet. And then down here, this cluster issuer concept here is also not specific. I just copied and pasted almost all of this from the internet, from documentation, into this file, into this provisioning script. So there's very little here that's customized to that I customized myself. Not yet. I'm running out of ways to fill the time here. I'm also running out of time. But while we're waiting for that, let's also open up the Rails app definition here. Now, notice we've got this abstraction called a Rails app. I don't know if you can read it very well, but basically this concept here, like this is not something that Kubernetes understands natively. This is provided by that operator that I wrote. It defines this concept called a Rails app that our Kubernetes cluster can understand. And then, this is just we give it a name, we tell it what container image to pull. Environment variables, these are things that you would need for your app on Heroku as well. You have to set up your environment variables. And our entry points here, these are the things that we would put it into the proc file, right? We have our a web server, which is just running Rails server. It's going to be running on port 3000. This is the domain name we're going to run it on. And then it also does health checks. And the health check here, the purpose of the health check is so that we can provide 0 downtime deploys. And minimum configuration for this is only 2 lines of code. If you're doing it with raw Kubernetes container specifications, then you're looking at I think 3 or 4 lines of YAML instead of 2. But it's still ultimately not all that complicated. I shouldn't say not all that complicated. That's actually really complicated if you're not using something like this. And the other bit is our Sidekick app here, right? And again, this is just saying Sidekick runs bundle exec Sidekick, and then our before create will run db schema load, and our before update runs db migrate, right? This is basically providing a Rails app abstraction for something that does not understand Rails apps. Are you serious? We still don't have an IP address on this?
It's a live demo.
So this is not just to show that, like, yes, I wrote something no, this is to show that you can also use other abstractions, that not just the raw stuff that Kubernetes provides. So I'm going to just double check my my load balancers. Oh, this is going to get embarrassing.
No, this is great, because this is what we'll be doing. Telling us
May, you are so encouraging. It has an IP address. Why is it telling me otherwise? Okay, looks like, all right, we're good, I think. Actually, before I go that far, let's come back over here. We're going to rerun this provisioning script. So another really cool thing about this is that we can rerun these at will. These are idempotent. So it's gonna check all these things. Like, cool, it's fine, and then I can just hit when it pauses, for the pause that I added in there in that script, I just hit enter and go through it. So now that we have that configuration, what we're going to do is we're going to come over here and we're going to set up our DNS. I always put it at 60 seconds when I don't know what I'm doing. And we're going to apply this one to the exact same one, same thing, 60 seconds. Now, the Rails app, now since I've done that, basically everything at, my domain that I've defined and all of its subdomains are now going to point at my load balancer. So I can take this this domain here, and it will automatically provision all these things that I need. So we're going to say kubectl apply -f Rails app, and then what that will do is it will spin up the before create task that we had, which is going to run our DB schema load. Unfortunately, this also takes an undefined amount of time, so I may have to fill more time. So what this is going to do is once it actually gets the container up and running, it will then run the DB schema load, and then after it finishes, it will start spinning up. Oh, there we go, it's running. It will then spin up our web and Sidekick entry points, and also this HTTP solver. This is for cert manager, which will provision our TLS certs. And now that is, the HTTP solver is still running, so. Now we can come over here. This is probably not going to work right off the bat, so I'm going to wait and give it a sec. We can check on our certificates over here. And it says that the TLS certificate, we can see here that ready is false. So the TLS is not available for it yet. And we can actually look and see what's going on. We can find out there's an order resource that we can look at. And then we can see that, again, like I was saying, we have all this visibility. So it created a challenge resource. Like, okay, cool, what's a challenge? It does a challenge response to validate this TLS cert to make sure that you own the domain. And this unfortunately looks like it's not going to work. I may not have waited long enough for some of this stuff to propagate, but if it would have worked, it worked several times when I was rehearsing this talk. It's entirely possible that I overdid it on Let's Encrypt, and Let's Encrypt is rate limiting me. Entirely possible. So, but that is a quick kind of like overview of how you would deploy a Rails app to how you might deploy a Rails app to Kubernetes very simply. I apologize that the TLS did not totally work. Again, like that is the nature of demos. Are there any questions? Question in the front. Yes, probably. So the question the question was that this dashboard for Kubernetes, this terminal-based dashboard, is pretty wild. And was there a dog emoji? And yes, there was, because it's called K9s, which is a play on K8s, right? K9s, dogs. The question was because the Sidekick process or the Sidekick pod does not have health checks inside of here, where it's just just the name and the command being run. How does it not get killed? If there are no health checks, it is assumed that it is healthy as long as it is running. As soon as the process is terminated if it crashes or anything like that, Kubernetes will spin it right back up. So, any other questions? The question was, I have my environment variables embedded directly into the file. Is there a way to do encrypted storage? There is. You would need to install something like Vault to do encrypted environment variables. Kubernetes does have a concept called secrets, but they're not encrypted. They're just base 64 encoded. You can because it's a separate type of resource. You can control access to it. You can use it in production.
But it's not at rest.
But no, it's not properly encrypted. No. The question is, if you have a Heroku app already, what is the smallest thing that you need to do to get it running on Kubernetes? The big one is to write a Docker file to be able to compile those containers, and then once you have that container, shove it up exactly like I did with this. Hopefully your TLS certs will work a little bit better. Because a lot of the things that Heroku talked about, and this is actually something I meant to put in my slides, and I appreciate you asking this question because I totally forgot to put them in there, is that Heroku introduced the concept of a 12-factor app, right? And so with Kubernetes and that whole ecosystem, they call that cloud native instead. They're not a one-to-one mapping of terms, but a lot of the things that Heroku talks about with the 12-factor app is a big part of what cloud native means. So a lot of overlap. I do have one more minute. Oh yes, the comment was that you can use build packs to build containers now. That's right. The cloud native build packs is a big new push for inside the Cloud Native Computing Foundation to make that transition from platforms like Heroku that use build packs to containerized environments. And that is all the time that I have for today. I appreciate every one of you for coming to the talk.